Hello and welcome to the course on inheritance. Inheritance in object-oriented programming. In C++, we are going to see the concept how inheritance works. I am Professor P. A. Satarkar, Assistant Professor in CSE Department, Shri Vitthal Education Research Institutes, College of Engineering, Pandharpur. This is the outline of the course. I am going to cover concept of inheritance, what is inheritance, why it is required, and how to use inheritance in our programming. We are going to see the simple example of inheritance, the base classes and derived classes, syntax for the derived class, types of inheritance. Let us see the concept of inheritance. What is inheritance? To inherit or transfer the properties or capabilities from an existing class or existing classes. So already we know the concept of class. So class has its data members and member functions. So from one class we can transfer those characteristics to another class. The existing class is called as base class, while the inherited class is called as derived class. So we can pass the base class contents or base class properties to the derived class. So this concept is called as reusability. The two classes in the inheritance must have the relationship in terms of code reusability. So this is the important feature of object-oriented programming. By using inheritance, we can transfer the properties and hence the code is reusable. Now, why inheritance is required? So first, already we have considered the code reusability. So reusing the already existing code saves time and money, and program becomes more reliable, as we already know the code which is written in the base class is giving us the proper output as per our requirement. So if we are using that code again in the derived class, the program reliability will be more. Better program solving and program design. So as we are reusing the code, the number of times required to enter those characteristics in the derived class gets saved. So problem solving will be better and the program design will be compact. Now see the concept of inheritance. So real-time example is if a base class is circle. So if you can observe here, there is a circle with radius r. So if we want to calculate the area of circle, we have the formula pi r square, that is 3.14 into r. Now if I am going to derive a sphere from it, sphere is a three-dimensional structure. So area of sphere is 4 into the area of circle. So if we are having this base class circle and we are having this area calculated earlier, this calculated area, this data I am going to reuse in my derived class sphere. So the time required to do this calculation will get reduced. I am going to use the properties of the base class here two times to calculate the area as well as to calculate the volume of the sphere. So sphere is kind of circular shape which has certain properties of the circle. So all those properties of the base class get transferred into the derived class. Second example we can see here is the base class employee. So if we consider any organization, employee has its ID, name, salary, then the constructor employee and show records. So if we want to display the records of any employee, I am using this member function show. Now if I am going to have a derived class manager, so manager is also one of the employee and manager holds all these things. Manager holds ID, manager has name, manager has salary. So all these data members, these can be reused in your derived class manager. Again, manager can have its own data members and member functions, such as the responsibilities of manager can be defined separately. For example, office related, bonus related. So all those all those extra things can be added into derived class. Next, we are going to see the characteristics of base class. It has all features of objects in that category. It is a general description of all objects in that category in terms of data members and member functions. Now, what is derived class? Derived class has a detail and specific features of the object in the class. So it has all the features of the base class plus it has its own features. So it usually has more capabilities than the base class in terms of member data and member functions. So we have seen right now the example of employee. Employee manager has its own set of attributes, but whatever the properties of employee class are there, they are transferred as it is to the manager. So manager has all the properties of employee plus its own properties. Now let us see the syntax for derived class. So syntax is class is a keyword, then you have to specify the derived class name. Here you are having the colon, then access type or access level. This can be private, public or protected, and then from which class you are deriving the derived class, that base class name you have to write here. So if I want to see the previous example, then your class derived class is the manager class, then this colon, then either you can use here public or private, followed by the base class name is employee. So my syntax will be class manager colon public and base class name employee, where access levels we have already seen they can be private or public. So there is difference how to define this access level, that we will see in the next lecture. Any class can serve as a base class. So here any class can serve as a base class, even derived class also can be a base class. Now let us see the types of inheritance. So there are total 5 types of inheritance. First, it's simple inheritance. So as the name itself suggests, the construction is simple. A single base class derives single derived class. So here one base class gives you one derived class. If this type of construction is there, then that inheritance is called as simple inheritance. Multi-level inheritance. Here a derived class can be served as base for the next level of inheritance. That means we are deriving a class from already derived class. So it is your multi-level. So there exist multiple levels. Then comes multiple inheritance. There are more than one base class to derive one or many derived classes. So here base classes are more and you are going to get the derived classes from it. Hierarchical is exactly opposite. Here you are having single base class and the derived classes can be more than one. And hybrid inheritance is the combination of any of the above types of inheritance. So let us see diagrammatically. This is the example of simple inheritance. A single class derives one single class. So when 1:1 ratio is maintained for the base and derived, then we can say that it is a simple inheritance. Second is multi-level inheritance. So here you can observe there are multiple levels. This is the base class from which the derived class is obtained. Again from this you are getting one more derived class. So we are deriving a class from already derived class. So these are the different levels of inheritance. Next is multiple inheritance. So here multiple base classes are there and you can have multiple derived class. Next is hierarchical inheritance. So from one base class we are deriving more than one derived classes. And the final is hybrid inheritance. So it is a combination of any two of the inheritance types. So here I have taken one base class from which we have derived two derived classes. So this is the example of hierarchical inheritance which is followed by the single inheritance. So whenever it is a combination of hierarchical inheritance followed by a single inheritance, in this example forms the hybrid inheritance. So hybrid is the combination of any two type of inheritance. Thank you.